So hello everyone, so welcome back to my channel. So for this video, I will mention about stretches in BC Pre-Calculus 12. And what we are going to expect to know is to know these four terminologies. So if I mean the stretches, I have four terminologies, which is vertical expansion, horizontal expansion, vertical contraction, and horizontal contraction. So what do we mean by vertical expansion, something like that? So let's see in the following scenarios. So in this video, I will use the circular clay illustration to help you guys understand what stretches. So assume I have the circular clay here and I want to push the circular clay in this direction. So after I push the circular clay in this direction, I will get the shape looks something like this. It's not a circular shape anymore, but it looks like ellipse, right? So you will see that the vertical component of this ellipse becomes larger than this one, but the horizontal component of this shape is smaller than the circle. So basically I can claim that this shape is undergo vertical expansion and also horizontal contraction because I know that the vertical component is become larger and also the horizontal component becomes smaller. So I have these two terminologies to describe the shape. So this is my second scenario. So assume that this is my circular clay and I'm going to push the clay into this direction and this shape is what we got. So you see that this shape, you see the horizontal component is become larger and the vertical component is become smaller. So how could we describe the shape here? So I can use these two terms to describe the shape. So we have vertical contraction. So you see that the vertical component becomes smaller. Horizontal expansion. So you see that the horizontal component is become larger. So either these two terminologies is fine. So I hope you guys all have basic idea what the stretches is. So basically next I want to apply the stretches concept in a function. So in this case, I'll show you the function y equals a times f of x. So a is a constant number and I want to investigate how the a value will affect original function f of x. So basically a value will describe the vertical stretches. So which means that the a value affect the vertical component of the function. So how is it affect the vertical component of the function? So let's see. So just assume that a equals to 1. So when this number a equals to 1, so 1 times f of x equals to f of x. So you will see that the shape will be identical with the function f of x if a equals to 1. So what happens if a value is greater than 1? And what happens if a value is between 0 and 1? So let's see. So I will use the graphing calculator to help you understand how the stretches, how the a value will affect the original function. So in this example, I show you we have the original function. So I call this f of x equals to x squared. It's a basic quadratic function. And I represent this function in the red curve. And also the blue curve here, I have this function y equals a times f of x. So this a value depends on this a value. So I will move this point back and forth to see how this a value will change the original function. So let's see. So assume that at this time a equals to 1, right? So when a equals to 1, I know that the original function red curve is identical with the blue curve function, right? So you see that they are identical. So what happens if I move this point to the right? So if I move this point to the right, the a value increases. So what happens if a value increases? So you will see that the blue curve, the horizontal component become constricted. So which tells me that the vertical component is become expanded. So right, you see that if I further increase a value, right, the vertical component becomes larger and also the horizontal component becomes smaller. So could you see that? Right. So if I move back a value, you will see that the shape is coming back when a equals to 1, right, is identical to the red curve. So what happens if I move the a to the left? So when a value is between 0 and 1, so you could see that the horizontal component becomes greater, so which tells me that the vertical component becomes smaller. So this is a conclusion. If the A value is greater than 1, I assume that the vertical portion of the f of x is expanded. So when A is between 0 and 1, so this number is a decimal places. So basically, the vertical component, if I times a number with the decimal places 0 point something, I will got the vertical component, the y function, becomes smaller. So next, I will investigate how the A value being negative affect the original function f of x. So let's start A value equals to 0. So when A value equals to 0, you see that the blue curve disappear. So basically, if I move to the left, the A value become negative. So when A value, this function becomes negative, you will see that the negative sign is outside the function. So when the negative sign outside the function, which tells me that original function is being reflected in x-axis. So you see that, right? So when A is negative 0.4, you could also notice that the horizontal component of this parabola is expanded, so which tells me that the vertical component is constricted. So it was when A value equals to -1, this shape and this shape is identical besides a reflected one in x-axis, right? Could you see that? So basically, if I further decrease the A value, right, you will see that the vertical component is become larger and the horizontal component becomes constricted. So to conclude, when A value equals to -1, the function is being reflected in x-axis and the shape is identical with the function. And also when A value is less than -1, you will see that the vertical component is expanded and also the function is being reflected in x-axis. So there are two pieces of information, so be careful. And also when A value is between -0 to -1, the function is reflected in x-axis also, then the function is constricted by factor A.